Is on 3.7 gas laws. We will be covering all 5 gas laws in this section. Make sure you stay in pace, and anytime you do not understand anything, make sure you pause. This is a long section, so be prepared for that. That we used in this section. So first, we're gonna go specifically on pressure. Pressure units are the following: atmospheres. You will see the abbreviation symbol for atmospheres is ATM. The unit pascals or kilopascals, you will see a PA for pascals, and kilopascals, you will see that kPa. Millimeters of mercury is another pressure unit we're going to see, and that's abbreviated with the symbol mmHg, and then pounds per square inch, so that's the PSI. I want you to notice and take a look at this bottom part where you will see how all of these are equal to each other. A lot of people think that 1 ATM is only equal to 101,300 pascals. That's not true. 1 ATM is also equal to 101.3 kilopascals, and 1 ATM is also equal to 760 millimeters of mercury, and 1 ATM is also equal to 14.7 psi. Just like 101,300 pascals is also equal to 760 millimeters of mercury. So all of these numbers at the bottom are equal to each other. You will have this in what I call a cheat sheet that you're going to use, because you don't have to memorize how they're equal to each other. But what I want you to know is that all of these are units for pressure. Temperature as well. That's another unit that we're going to be basically another form of measurement that we're going to be seeing. A unit for temperature that we use here is something known as Kelvin. Why do we use Kelvin? Well, Kelvin has something that we call an absolute zero, meaning nothing falls below zero in the Kelvin scale. That's why it's used in a lot of chemists, and a lot of physicists use Kelvin when they measure temperature. Okay, so we need this because in gas laws calculation, we can never have negative pressure or negative volumes. As you know, we can't have a negative volume of something. We can't have a negative pressure of something. That's why Kelvin is used instead. Please understand is you will see this a lot in problems when we're doing problems. Something known as STP. It's abbreviated as standard temperature and pressure. So what does that mean? When we talk about a standard temperature, the standard temperature normally in any problem is going to be 273. So anytime you see this word, standard temperature, in a problem, you know that is equal to 273. You will also see something known as standard pressure. The standard pressure is basically the pressure that is known as 1 ATM. Okay, or it's equivalent to any other unit that you see. You will see a lot in problems. It's going to be abbreviated as STP. So this actually signifies two numbers. Those two numbers are 1 ATM and 273 Kelvin. So they are already giving you the pressure and temperature when they're giving you STP. Those are used to explain kind of like how a gas behaves. How is a gas behaving regarding its temperature? How is a gas behaving regarding its pressure? How is a gas behaving regarding the number of moles, the volume, things like that. So basically, gas laws are a way to kind of explain the kinetic molecular theory. Laws that we're going to talk about have what we call a before and after in gas laws. So all of these gas laws are, okay, this is a scenario one. What happens if I change the pressure, for example? How would the after effect of it be? What would it be? What would be affected? Or let's say, for example, this is all the information I have about this gas. What if I change the pressure or the temperature or the number of moles? What would the after effect be? So in the first 4 gas laws, you will see this a lot. I will give you the formula for these. So make sure you guys are going to have like what I call a cheat sheet again, that make sure you have it when you're doing the quiz, when you're doing the worksheets. Known as Avogadro's law. Avogadro relates the number of moles and the volume to itself. So this formula will look something like this. V1 stands for the volume, so the volume initially before the change. N1 stands for the number of moles. Again, the number of moles before the change. Now that is equal to the volume 2, basically after we have done a certain change to this gas. What would the volume look like? That is equal to V2 over the number of moles in the second scenario. Remember, what you need to remember is volume must match. Meaning, if you start with liters, you better end with liters. If you start with number of moles, is usually the mole is the unit. If you have moles on one side, the mole should also be the unit that you have on the other side. All right, so here we have an example of Avogadro's law. It says a sample with 0.15 moles of gas has a volume of 2.5 liters. What is the volume if the sample is increased to 0.55 moles? So a key thing that I always like to tell students is underline what numbers you have along with the units so you know what you're working with. So first we have 0.15 moles, then we have 2.5 liters, and then we have 0.55 moles again. So those are the three numbers I'm working with. So if we remember, Avogadro's law was volume over moles equals volume over moles. So what does that look like? So again, it's V1 over N1 is equal to V2 over N2. All right, so this is how our formulas look like, and we're gonna put these three in here, and then one of these is gonna be our x. That's the one that we're solving for. So what I like to do is make a list of what are the variables that I have and what is the variable that I am missing. So let's start with 0.15 moles. Moles are your units for N. Okay, these are N units. That means that it's one of these. So it says a sample with 0.15 moles of gas has a volume of 2.5 liters. As you can see, normally what's in your first sentence, that's your ones. That's what you begin with. Because then if you read your second sentence, it says, what is the volume of the sample is increased? So this is your after effect. So these two belong on this side of the formula. They are part of the at V1 and N1. So 0.15 moles, that has to be my N1. Okay, that's my N1. That's what I begin with. Then what is 2.5 liters? Well, 2.5 liters, that has to be my V1. Okay, now I have changed this. Now the second part, this number right here is going to be part of my either V2 or N2 depending on what unit I have. And we have moles, so that means that has to be my N2. So 0.55 moles has to be my N2. All right, so now now that we know which variable stands for, what number stands for which variable, we're gonna input this in our formula. So V1, like I said, is 2.5, so we're gonna have 2.5 over N1, which is gonna be our 0.15, and that's gonna be equal to V2. We don't know V2, so I always like to put it as X because that's the variable we're trying to figure out. Then N2 we have, which is 0.55. Okay, I want you to notice, I didn't put any units here because I already know the units, but if you want to, if it helps, you can put the units in here. It's up to you. Now it just becomes a simple proportions, and most of you have done proportions now, so it just becomes a simple proportion where you're going to cross multiply and divide by this. So once you do this, so I want you to pause it and try this out in your calculator. And if you do this, it's 2.5 times 0.55 is going to give you 1.375, okay? So once you cross multiply this, you're going to get 1.375, and that's going to be equal to 0.115 times x. Now you want to solve for x, so obviously you're going to divide by 0.15, 0.15. Okay, and now you should get a big number like this, 9.166666667. Remember, you have to use significant figures here. Yes, significant figures we are still using here. So you need to make sure that you have to use the least amount of sig figs. This is a multiplication and division. So you are following the multiplication and division rules, which state that whichever one has the least number of sig figs, that's how many you use. So in the first one, we have 2 sig figs. In this one, we have 2 sig figs. And this one, we also have 2 sig figs. Remember, these are leading zeros. They never count. So my answer should only have 2 sig figs. That means that my answer should be 9.2 in liters because V2 is in liters since V1 is also in liters. So that's your final answer. The second law we're going to talk about, this also has that before and after basically hold to it. So if you look at Boyle's law, it relates to pressure and volume. So now we're going to look at pressure for this first time. The first one we were looking at number of moles and volume. Now we're going to be looking at pressure and volume. So we are looking, number of molecules are held constant here, so we don't take consideration into that. What does that mean, held constant? It means that the number of molecules don't change from the before and after effect. So pressure is going to be abbreviated as P. Volume is going to be abbreviated like as V, like we said before. The units must match and the volume units must match. Remember, what does that mean? That means pressure. If you're using ATM, then the pressure 1 is ATM, pressure 2 needs to be an ATM as well. If volume is being used in liters initially, then volume 2 has to be in liters as well. So always make sure your units match, your volume units match, your pressure units match. So let's take a look at this one. Now this is an example of Boyle's law. So it says a gas sample is 1.05 ATM when 2.5 liters. What is the volume if the pressure is changed to 0.980 ATM? Again, remember, best thing to do is just underline your numbers with your units so you know what you're working with. So we have 1.5 ATM. We have 2.5 liters. We have 0.980 ATM. Again, as you notice, and you will have this in your cheat sheet, ATM is pressure, so I know that's what I'm working with, pressure. We looked at L before, L is volume. So this is the pressure and volume, and we automatically know this is Boyle's law. So what does Boyle's law look like when we look at the equation? Boyle's law looks like the following. Volume 1 times pressure 1 is equal to volume 2 times pressure 2. Okay, so now we have to figure out where these three numbers are going to go and which one is going to be our X. So if we start off first with 1.05 ATM, remember ATM is pressure. Now, because it's at the beginning of the sentence, I know that's pressure 1. No, never is pressure 2 going to be at the beginning of the sentence. So anytime you see a pressure unit, it's at the beginning of the sentence. It's the first pressure unit you see, you know that's pressure 1. So we know pressure 1 is going to be 1.05 ATM. Okay, now let's keep going. We have 2.5 liters. Now again, this is the first volume we see, and because it's at the beginning of the sentence, that means that it has to also be volume 1. So 2.5 liters is our volume 1. Let's keep reading. What is the volume if the pressure is changed to 0.980 ATM? We see pressure again. So that means that has to be our pressure 2. If we have seen pressure again. And what our unit are we missing? We're missing V2. So we don't know what V2 is. That's our question mark, or better yet, that's our X. Okay. So now that you know what numbers go in with what variables, you're gonna fill these in. So let's do that right now. We have volume 1, that's going to be 2.5. That's going to be multiplied by pressure 1, which is 1.05. That's going to be equal to volume 2, which we don't know, and that's going to be multiplied by pressure 2, which is 0.980. Okay, so now what I would do if I were you is obviously order of operations. You do your multiplication here on this side first. So that is going to be 2.5 times 1.05. Okay, you got 2.625. And that is equal to 0.980 times X. Remember, it doesn't matter if the X goes before and after, because multiplication, you get the same thing before or after. So we want to isolate X. We want X by itself. So we're going to divide 0.980 to both sides. Okay, so you're going to take this in your calculator. You're going to divide this number by 0.980. Okay, so you're going to get this big number, 2.678577143. Now, same thing that we did before. Whichever has the least amount of sig figs, that's how many sig figs your final answer should have. 1.05 has 3. 2.5 has 2. 0.980 has 3. Why does it have 3? This 0 doesn't count, but this 0 does, because that's a trailing 0, and since there's a decimal, that 0 counts. So what would our final answer look like? Our final answer should only have 2 sig figs, so that means our final answer should be 2.7, since the 7 makes the 6 round up. And our unit, what unit are we using? Well, since it's volume 2, we are going to use the volume 1 unit, which is liters. And Charles' law is our third law that we're going to be using. And as you can see, Charles' law relates temperature and volume. This means that the pressure is held constant, meaning the pressure doesn't change before and after. And the other thing that's held constant is the number of molecules. They're the same before and after. So volume is over temperature. V1 over T1 is equal to V2 over T2. Remember, the first thing is that you need to make sure is that temperature must match, meaning temperature must be in Kelvin. So T1 and T2 always have to be in Kelvin. If they're in Celsius, you need to make sure you change it to Kelvin. And how about for volume? Volume must be in liters, both V1 and V2. So this is an example of Charles' law. So Charles' law looks at volume and temperature, if you remember that. So a problem like for Charles' law would read the following. What is the final volume if a 10.5 liter sample of gas is changed from 25 to 50 Celsius? So what would that look like? Now, again, remember, same thing that we've done before. Please underline all the numbers that you have. So we have 10.5 liters, 25 Celsius, 50 Celsius. Now, what does Charles' law look like? So if you remember, Charles' law is going to be V1 over T1 is equal to V2 over T2. All right, so this is how the setup for this one will look. Now, let's do our list to see what we have, and let's see which one of these is going to be our X. So remember, anything at the beginning of the sentence, it's always in the one, so it's going to be on this side somewhere. So 10.5 liters, remember liters is for volume. So our V1 is 10.5 liters. All right, so how about 25 and 50 Celsius? Which one is going to be our temperature 1? Which one is going to be our temperature 2? Well, if you take a look at this, we have 20 is changed from 25 to 50, meaning 25 is going to be our initial temperature because that was what it was initially, and it's changed to 50 Celsius. So 25 Celsius is going to be our T1, and then our T2 is going to be 50 Celsius, which means that our V2 is going to be our X. All right. So now, what did and previously I said that temperature must always be in Kelvin because Kelvin has what we call an absolute zero, meaning nothing can be negative. Celsius, as you know, and Fahrenheit can both be negative, so we don't want our temperature units to be in this. So how can we transfer, how can we make Celsius into Kelvin? It's actually pretty simple. It was in the slide previously. I did not talk about it, but to any Celsius, you can just add 273. If you add 273 to any Celsius, I'm going to use a darker pen. If you add 273 to any Celsius, then you will get your temperature in Kelvin. So if we do 25 plus 273, we should get 298. And in this case, we're not going to round to any sig figs because there is no decimals here. So no decimals means you just take everything that's given. 50 plus 273 gives you 323. Okay, so now these are your new temperatures in Kelvin. These are the ones that you're going to use in your problem. You're not going to use 25 or 50. You're going to use these new ones, okay? So let's put all this in the formula. So V1, we have 10.5 over T1, our temperature 1, which is 298. And that is equal to V2, which we don't know again, and T2, which is 323. All right, and again, simple proportion. 10.5 times 323 okay, when you do 10.5 times 323, you get 3,391.5, okay, and then 298 times x is just 298x. All right, now we want to solve for x, so we're going to divide by 298 to both sides. So we can get rid of the 298 on this side. So the number that you have in your calculator, divide by 298, and you should get 11.3808725. Now, again, like I said before, always you will always want the least number of sig figs, and this is a multiplication and division. Now, I want you guys to do the following. I want you guys to actually take in the consideration just the significant figures of the Kelvin. Don't take this in consideration the significance of the Celsius, because technically the Celsius did not go in this problem. What went in this problem are these numbers, okay? So don't take into consideration how many sig figs are here in the 25 and 50. So let's start at the top. 10.5 has 3 sig figs, as that's a middle zero, it always counts. 298 has 3 sig figs, 323 has 3 sig figs. That means our final answer should have 3 sig figs, so we're gonna cut down 11.38 to 11.4 liters. And again, it's 11.4 because it's 11.38, which means that the 8 makes the 3 round up. This is the last kind of law that looks at before and after. We do have one more law still that we have to talk about, but combined gas law, as it sounds, it is combining the Boyle's law, Avogadro's law, and Charles' law all together. So how would this look like? We have P1 times V1 over N1 times T1, which equals P2 over V2 divided by N2 over T2. So as you guys know, pressure, volume, number of moles, and temperature, all that's what P, V, and NT stand for. You guys have to remember that whatever P1 is on one side, P2 has to be the same units regarding pressure on that side. Whatever V1 is on the left-hand side, V2 also has to have the same units. Whatever T1 and T2 are, both of these must be in what we call Kelvin, all right? So for the combined gas law, like I said before, this one is probably the one that we're gonna have the most numbers for, because it takes into consideration all of the 3 laws mentioned above. So how would the combined gas law look like when we look at the at a problem? So it says, what is the final volume if a 0.125 mole sample of a gas at 1.7 atm, 1.5 liters, and 298 Kelvin is changed to STP and particles are added to 0.225 moles? All right, so as you can see, lots of numbers, lots of things to deal with. So we first always, like I said, underline all the numbers with your units. 0.125 moles, 1.7 atm, 1.5 liters, 298 Kelvin. STP is also one that you're going to want to underline, because STP is also stands for 2 numbers. If you remember at the beginning of the video, we talked about what STP stands for. And then we have 0.225 moles. All right. So how would this look like for our problem? So let's take a look at, first of all, if you remember, let's take a look at the equation. The equation will look like the following. It's going to be V1 times P1 over N1 times T1, which is going to be equal to V2 times P2 over N2 times T2. Okay, this is your combined gas law. And we're going to make our list just like we've done before first, because that assures us so we can identify where our X is going to be. So again, remember all the first numbers that you're going to have are always going to be your 1. So these are always going to be your left-hand side of the equation. So 0.25 moles, as you remember, moles stands for N. So our N1 is 0.125 moles. Okay, if we keep reading, 1.7 atm, that's obviously our first pressure. All right. And then 1.5 liters, that's our first volume. All right, and 298 Kelvin, that's our first temperature. So we have all our N1, P1, V1, and T1. Now let's keep going. And now we see it's changed to STP. STP stands for standard temperature and pressure. So our standard temperature, if you remember, look back, and also you're going to have this in your cheat sheet. Your standard temperature is going to be, so that's going to be our T2. That's going to be 273 Kelvin. Okay, so that's our standard temperature. Our standard pressure, So our P2 is going to be 1 ATM. And how come I chose 1 ATM? Because it's our P1 is an ATM as well. And if we keep going, we have 0.225 moles. So that's going to be our N2. So if we look at this list, we have T1 and T2, we have P1 and P2, we have N1 and N2. What are we missing? We are missing volume. And that's what it's asking us at the beginning. What is the final volume? So our V2 is going to be our question mark, better yet known as our X. Okay, so let's fill all of these numbers in for our equation. So V1, we have 1.5, 1.5. That's going to be multiplied by P1, which is 1.7 ATM. All over N1, which is our 0.125, times T1, which is our 273. All of this is equal to V2, which we don't know. P2 is 1 ATM, all over N2, which is 0.225, multiplied by T2, which is 273. All right, so we take a look at this. We are using this equation again. Remember, cross multiply times cross multiply times cross multiply, cross multiply times cross multiply times cross multiply. So this is a lot of numbers to keep track of. A key thing for these kinds of equations, never round till the end. You want to make sure of that, guys. If you round in the beginning, that could actually change your answer, or you would not get the same answer I did. So make sure you round till the end. So we're going to start at the top. We're going to do 1.5 times 1.7. And we're going to keep going. We're going to multiply it by this and this as well. Because multiplication, it doesn't matter what order you do it in. It just matters that it gets done. You multiply correctly times all of them correctly. Sorry, I misclicked the wrong 1.5 times 1.7. 0.225 times 273. Okay, so I'm going to write this whole number down because I want to keep track of all this. So I multiplied this, 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 and that. So that was 156.63375. Okay, and that's going to be equal to whatever we multiply here. So we're going to multiply 0.125 times 273 times X, there's nothing we can do there, times 1, which is going to be equal to 34.125X. All right, so we multiplied this, 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 and that. We got rid of everything. So now this becomes a simple division one. So we want to make sure we divide 34.125 to both sides. And remember, as you can see, I'm not rounding it till the end. So I'm going to do 156.63375 divided by 34.125. Okay, and I got 4.59. Now, before I write all of this, I don't know if I need all of this. I don't know if I don't. We have to look at significant figures. So let's look at this. We have 3 sig figs here. We have 2 sig figs here. We have 2 sig figs here. We have 3 sig figs here. We have 3. We have 1. Oh, sorry. In order to avoid this, I want to make sure I talk about this. In order to avoid only 1 sig fig, because numbers like these, I mean, we can still round it to 1 sig fig. I'm going to tell you guys, always do 1.00 for ATM. And make sure you do 1.00. This way you have 3 sig figs instead of 1. I want to make sure you guys get that. Make sure you watch this, look at this. Do 1.00 so you can have 3, and here you have 3. You always want to make sure at least you have 2 sig figs because that's a more accurate answer. So if we look at back at our calculator, we should have 4.59, which means our answer should be 4.6 liters. All right. What we this is the only kind of law that is not like the others. Due to the fact that this doesn't compare before and after. It's kind of at one standard situation, okay, just at one situation. What is the ideal gas law equation? That's P times V equals nRT. So P is obviously stands for pressure, V is for volume. Those are the two that you're very familiar with, and that's equal to N, which is number of moles, R, which is a gas law constant, which I'm going to talk about in just a second, and then we have temperature. What you have to remember, same thing that we've done before. pressure, well, these don't have a, since they don't have a before and after, they only have to be in a certain, they only have to be at a certain unit. The only one that you have to remember is for temperature. It has to be in Kelvin still. That's the only one that you have to make sure it's still the same. Now, what are the two possibilities for R? R, since it's a constant, it means that it's going to be the same number no matter what situation. But that number, it all depends on what units the pressure is under. So what R will be 0.0821 when we are using ATM pressure. Okay, so these are just the units for R. Don't really worry about these. The only one that you have to worry about is ATM. That means that if our P, our pressure, is in ATM, we are using the R 0.0821. How about if our pressure is in kPa, kilopascals? If our pressure is in kilopascals, the R that we are using is 8.31. But you have to choose one of these. It all depends on the pressure units. And remember, another thing is that volume must be written in liters in order to use R. So volume is another one, like temperature, that has to be in liters. Temperature has to be in Kelvin. Volume has to be in liters. All right, so this is what an ideal gas problem would look like, guys. So it says a sample with 0.55 moles of gas is at 105.7 kilopascals and 27 degrees Celsius. What volume does it occupy? So as you can see, there's no what if we change it, what is the final volume, what is the initial volume, things like that. It is a one-time situation, just at one instance. So still same thing, you always highlight the numbers that you're given along with the units so you know what you're using. We are using 0.55 moles, we are using 105.7 kilopascals, we are using 27 degrees Celsius. So we have three numbers. And what is the equation for ideal gas law look like? So it's P times V equals nRT. All right. So now let's make our list to make sure what we're working with. So let's start with 0.55 moles. Obviously, moles is always our N. So N is equal to 0.55 moles. All right, 105.7 kilopascals. That is our pressure. Kilopascals is for pressure. Right now, you've seen a lot of ATM, but kilopascals is also a pressure unit. So we have pressure is equal to 105.7 kPa. All right. Now we have 27 degrees Celsius. If you remember, that is our temperature unit. All right. So what are we missing? Well, in this case, it looks like we don't have V and we don't have R. But that's kind of, then we wouldn't be able to do a problem if we don't have R or we don't have V. We only need to have one missing variable. If you remember, R though is a constant. So you have a list. You have two options. You can choose one depending on what pressure unit you're using. So if we go back and we look, there is the 0.0821 and then there's the 8.31. So which one of those would you use? It all depends on the pressure unit. So the pressure unit that uses kilopascals, if you remember, is 8.31. And again, don't write the units for these because these have so much units. A lot of people get mixed up with them. Just know which pressure unit you need to use depending on what you're given. So we are using 8.31 because we are given kilopascals. That means that now volume is going to be our question mark, better known as our X. So let's start doing this problem. Pressure is 105.7 kilopascals. That's going to be multiplied times volume, which is going to be our X, which we don't know. N is going to be our moles. That's 0.55. R is going to be 8.31, and we're going to multiply that by T. Now, just forgot, T is 27 degrees Celsius. Like we said before, we do not want to use Celsius. We always want to use Kelvin. So we need to make sure we add 273 to make it into Kelvin. And if you add this together, you can see this is going to be 300. Okay, because 273 plus 27 is 300. So we're going to multiply times 300. Okay, so let's do this problem. Let's multiply everything to the right-hand side first, because obviously all that can be simplified. 0.55 times 8.31 times 300. gives us 1,371.15, okay? And that's going to be equal to 105.7 times x. And since we want to get rid of x, we're going to divide by 105.7. We're going to divide by 105.7. Okay, and if we divide these by 105.7, we'll get 12.9720908. All right, now let's make sure we use the correct number of sig figs for this. So let's take a look at this. Here we have 2. Here we have 4. Now here, this is where it becomes tough. We have technically 1. For these kinds of problems, I'm gonna let you guys not have to choose that one, because this is kind of hard to choose just one sig fig. I'll make sure though in the problems that I give, you'll never just have one sig fig, okay? So let's use 2 significant figures just so we can make sure we round correctly. So 12.97 actually will become 13, because the 9 makes the 2 round up. And what unit are we using? Since we have to figure out volume, it would be 13 liters. Those are all the 5 gas laws we will cover in this section. I know this is a difficult section. This is why, and because we have Monday off, this is why I left this quiz till Monday, just in case you guys have the whole weekend to ask me questions. If popularity says, you know what, we should have another little study session on Saturday or Sunday, I mean, I'm more than open to do that. We can have another YouTube live session, but just make sure you really watch this video. You look at your notes. This is not an easy section that we can really cruise by. So make sure you look at your notes. You do the worksheets. You do the examples. You email me any questions. All right. I will be on YouTube Live on Wednesday. Miss Nichols will be on YouTube Live on Wednesday at our regular hours. So please make sure you tune in.